Come back. Problem 18. Use Newton's method to find second and third approximation of a root. Okay, Newton's method or Newton-Raphson's method is to be used when you have an expression equals 0. Make sure right hand side is 0. The point is to find a root of this equation, that is, find a solution of this equation. As you can see, this is a cube. So there is, it's something that you need to use approximations for. They are telling us use x1 equals -1 as your first approximation. When you plug in -1, you get -1 here, -1 here, and +2, 0 already. So you have hit upon a solution. So you shouldn't really get further approximations. Okay, but in this is just an example of how to use our formula, Newton-Raphson's method. So whatever be your initial approximation, you're going to use that in the Newton-Raphson formula or the algorithm or the method. Xn plus 1 is xn minus fxn over f prime xn. That is, the next x is dependent on the previous x. That's all this says. A new x is dependent on an old x. That's how you keep approximating. So my function f is x cubed plus x plus 2. So its derivative is 3x squared plus 1 and nothing. x1 is 1. So x2 will be, wherever I see xn, I will place x1. Replace x1 by -1. Don't forget parentheses, especially when you have negatives. Parenthesis -1 cubed and so on. When you check, you get 0 on the top. So -1 minus 0 is -1. Okay? In other words, like I said, -1 is already a root. We shouldn't have any more approximations. And that's what we have found. x2 is also -1. Okay. What about x3? Well, the same formula applies. To find x3, you now place x2 in your formula. x2, x2, x2. Numerator is function, denominator is derivative, and here is the new x2, right? You plug in x2 and you get the same answer. You shouldn't have any more approximations, okay? But suppose you hadn't chosen -1, suppose you had chosen 0, then you will get something new in these places, all right? At present, this is fine. Why did I click that? Okay, it's good. Next problem, problem 19. It says, if f double prime is this, f at 0 is this, and f at 2 is this, find f. In other words, you have been given second derivative and two boundary conditions. You are asked to find the function itself. So if you know second derivative, how do I go to the function? I have to find antiderivatives, okay? So second derivative is given, boundary conditions are given. First derivative is an antiderivative of the second guy. How do you find antiderivative? So f prime is antiderivative here. So antiderivative of 4 is 4x. Antiderivative of 6x or x, increase the power of x and divide by the new power. Because it is antiderivative, don't forget the constant of integration, okay? Constant of antiderivative. Simplify, 6 over 2 is a 3. This is my first derivative. fx is an antiderivative of f prime. So I need to do this process again to get f. 4x. X gives me x squared over 2. Increase the power by 1 and divide by the new power. X squared. Increase the power by 1 and divide by the new power. C is a constant, so its antiderivative is cx, and you have a new constant d. Okay, simplify. 4 over 2 is a 2, 3 over 3 go away, it's just a 1 there. Cx plus d. Now you have two constants. Well, that's why you have two conditions. Let me plug in f at 0 is 5. What does that mean? When x is 0, my value is 5. So I'll write the value, plug in 0 for x and d, right? They all go away because they are being multiplied by 0, but d survives. So d is 5. You found this constant. D is 5. Now that is your fx. You have one more boundary condition. F at 2 equals 6. That is when x is 2, the value is 6. So value is 6. Plug in x equals 2. Alright. So 2 power 2. So when you simplify, this is an 8. This is an 8. And this is 2c plus 5. So 8 minus 8 go away. 6 equals 2c plus 5. Solve. 6 minus 5 is 2c, divide by 2. C is 1 over 2. So my fx is 2x squared minus x cubed plus x over 2 plus 5. I better type it in. You have 2x to the power 2 minus x to the power 3 plus x over 2 plus 5. Okay, until next problem then.